So, Jai Hind students, so this is our first lecture of the complex lecture series for our subject digital system design, and the topic is Quine McClusky method, which is also known as tabulation method, and we are covering a special case which is Quine McClusky method or tabulation method with don't care conditions. Okay, so let's start with the contents. So why we are opting this tabulation method or Quine McClusky method? Because we have observed that K-maps become complex for more than 4 variables. When we were solving 5 variable K-map or 6 variable K-maps, we saw that the grouping patterns were becoming very complex. So it is quite hard to prepare the layout for the 5 and 6 variable K-map, and then further the grouping patterns are also slightly complex. So to avoid that, we can opt for tabulation method, which is although a lengthier method but a systematic one. Okay. So for 5 and 6 variables, Quine McClusky method can be used, and this is also known as tabulation method. Why this is known as tabulation method? Because we will be preparing multiple tables again and again in this method. So that means we will be finding the minimized expression by preparing a series of tables. That means we will be doing table 1, table 2, table 3 and so on till we are getting the groups. Okay. So this is the basic of Quine McClusky method or tabulation method. So now let's say this is the question provided to me, minimize the following using tabulation method. So this is the question provided to me which is having some min terms and some don't care terms are there. Okay. So like the tabulation method without don't care, all the steps are same, first step, second step, third step, preparation of all the tables. The only difference which will be there in questions which are to be solved, which are having don't care and are to be solved using tabulation method, in the last stage when we will be preparing the prime implicant chart, but for the time being we can simply consider these don't care terms as min terms only. We will not be doing anything special with those don't care terms. We are just considering that these don't care terms are not there, and these are the part of these min terms only. To start with the questions, for 70 to 80% of the questions we will be considering these don't care terms as normal min terms only. So let's start. Okay. So writing all the terms in binary form, this is the step 1. So we have to write all terms in binary. So if we write 1 in binary, then 2 in binary, then 3, then 6, then 9, 1 0 0 1, 13, 1 1 0 1, 10, 1 0 1 0, 12, 1 1 0 0, 14, 1 1 1 0 and 15, 1 1 1 1. So this is the first step. We have written all the min terms in binary. Now we can go to the next step, writing the index of the terms. Index is the number of ones present in that particular min term. So if we check that in this, number of ones are 1, this is because this is the only one present in that term. Again here index is 1, here index is 2, here index is 2, index is 2, here index is 3, index is 2, index is 2, index is 3, and here index is 4. Okay. So we can see that there are terms from different index. There is index 1, it is index 2, index 3, index 4, and point to be noted here is that min term 0 is not here, otherwise index 0 is also possible. Okay. So if here before this 1 in this min term, if there would have been a 0, okay, so for that 0 the binary representation would have been 0 0 0 0, and it would have no 1, and that's why the index for min term 0 would be 0. Okay. So we have written the index, this is step 2. Okay, index of the terms, and now arranging the terms in increasing order of the index. So the first term, smallest min term with smallest index. So index 1 is this 1, 1 2, and you can see that there is no other min term which is having index 1. So for index 1 there are terms 1 and 2. Then index 2, you can check This is 3, 6, 9, 10, 12. So 3, 6, 9, 10 and 12. Then index 3. Index 3 you can check here. This is the first one, which is 13, and this is 14. So 13 and 14. Then index 4. Then index 4 is this 1, 1, 1, 1, which is 15. So we have segregated all these minterms in increasing order of their index. Now let's arrange them in tabular form, and that will be our first table. We have mentioned that it is known as tabulation method because we will be preparing a series of tables. So let's prepare the first table. So this is the first table. You can check here 1 and 2 from index 1, 1 and 2 from index 1. You can write here minterm. Okay, so this is minterm. 1 and 2 are from index 1. Then 3, 6, 9, 10, 12. 3, 6, 9, 10, 12. These are from index 2. Then you can check 13, 14 are from index 3. And then 15 is from index 4. So we have arranged all these minterms in increasing order of their index. And then in front of them, their binary representation. This is the binary representation of these minterms. Okay, so this is our first table. Now let's start preparing the next table. And the next table is actually the grouping of minterms from one index with the minterms from next index. That means we will be making group of minterms from one index with the minterms from next higher index. Okay, that means index 1 terms are to be grouped with index 2. Similarly, index 2 terms will be grouped with index 3. Index 3 terms will be grouped with index 4. And in case some index is missing, like here, index 0 is missing. So grouping of index 0 and index 1 will not be there. Similarly, if index 2 would have been missing, then there would have been no grouping between 1, 2 and 2, 3 because 2 is not there. And then in that case, 1 will not group with 3 because terms from one index can be grouped with next higher index only. And if that next higher index is not available, then it will not make groups with further next higher index. It is to be very much, it has to be very much clear that minterms from index 1 will make groups with minterms from index 2, not with 3. Okay. Even if 2 is not there, then minterms from group 1, index 1 will not make groups with index 3. Even if index 2 is not there, that has to be kept in mind. Okay. So this is what we have to do. We have to group minterms from one index with the terms from next higher index. Then what is the strategy? How we are going to do that? We will be making groups if two minterms differ by only one bit. That means rest other positions should be identical. That means if I check that this 1 is to be grouped with the terms from next higher index, let's say 1, 3, then I can see that this 0 and 0 is same, 0, 0 is same, this 0 and this 1, it is different, otherwise this 1 and 1 is same. So at 3 positions, 1 and 3 are identical, and at 1 position they are different. So they are meeting the criteria for grouping. So 1 and 3 can be grouped. Okay. So this is what we are going to do. So let's prepare the next table. Okay. So I am taking this term 1 from index 1 and I will be checking its grouping possibility with every single term from the next higher index. So if I will check 1 with 3, 1 with 6, 1 with 9, 1 with 10, 1 with 12. Okay. So let's check this 1 and 3. We can see that this is the point of difference. So 1 and 3 group is being formed and the point of difference is 0, 0, dash 1. Wherever you find the difference, that different position has to be left blank, or you have to show a hyphen there that it has been eliminated. So that means if I make group of 1 and 3, variable C will be eliminated. So that's why C is neither having 0 nor 1. Okay. Similarly, I can check 1 and 6, then 1 and 9, and 1 and 10, then 1 and 12. So all these combinations are to be checked, but I am giving you a shortcut. What is that shortcut? I need not to check all these combinations. I will check only certain combinations which are giving me the difference in 2 raised to power form. So 1, 3. So 3 minus 1 difference is 2. So difference is 2. If that difference can be written in 2 raised to power form, that means either it is 1, because 1 can be written as 2 raised to power 0, 2 raised to power 1, 2, 2 raised to power 2, 4, 2 raised to power 3, 8. That means if difference is 1, 2, 4, 8, only then grouping possibility need to be checked. Okay. I am not saying definitely it will be formed, but you will be only checking those minterm groups which are producing a difference in 2 raised to power form. Okay. 1 and 6, I will not check. Why? Because difference is 5. Similarly, 1 and 9, difference is 8. I can check. I have to check. So 1 is 0, 0, 0, 1 and 9 is 0, 0, 0. 9 is mistakenly written as 9 is 1, 0, 0, 1. Okay. So 1, 0, 0, 1 and 0, 0, 1. So this 9, 1 and 9, difference is 8 and it can be written as dash 0, 0, 1. Similarly, 1 and 10, difference is 9, need not to check. 1 and 12, difference is 11, need not to check. Proceeding further. Now the same thing has to be done with 2. Okay. Now let's check this with 2. 2 with 3. Okay. Then 2 with 6, 2 with 9, 2 with 10 and 2 with 12. But again, I will not be checking all the combinations. I will be checking only certain combinations which will be giving me the difference in 2 raised to power form. So 2, 3, 2 and 3, difference is 1. And let's check 0, 0, 1, 0, 0, 0, 1, 1. So 0, 0, 1 dash. Okay. And one most important thing, whichever minterm is participating in the group, I have to tick that. 1 has participated, 2 has participated, 3 has participated, 9 has participated, because at the end I will be requiring only those terms at which there is no tick. Okay. So this is where you have to be very much careful that you are taking every single minterm which has taken part in grouping. Proceeding further, 2 and 6, difference is 4, group can be formed. 2 and 6, difference is 4, you can check. 2 and 6, 0, 0, 1, 0, 0, 1, 1, 0. So 0 dash 1, 0. Okay. Then proceeding further, 2, 9, difference is 7, drop that. 2, 10, difference is 8, possibility is there. So 2, 10. Okay. So 2, 10, difference is 8. 2 is 0, 0, 1, 0. 10 is 1, 0, 1, 0. So dash 0, 1, 0, 2, 10. Okay. Similarly, you can proceed further. Now you can check that all the groupings from index 1 with all the terms from index 2. All grouping possibilities have been listed here. You can check that 6 has also participated, 10 has also participated, 2, 12, difference is 10. So 2 and 12 will not be making group. That's why it is not mentioned here. So you have to make a partition here that grouping from index 1 with grouping with min terms from index 2 is complete, and now I will proceed from index 2 and index 3 grouping. So I will be now grouping index 2 and index 3. That means every single term from index 2 will be checked for group, making group with term from index 3. So to make, so in this way I can complete this table. So for the sake of completion of this topic in this video lecture, I have prepared this table already. So this is the complete table. Okay. So this is a complete table. There was one correction, so I am making that correction. So this is the complete table which you can make, and you can check here all terms, all ticks. That means this table is not going to be used further, because every single term in this table has been ticked. Because at the end, keeping that in mind, because at the end I will be requiring only those terms at which there is no tick. Okay. So all terms are ticked. So this table 1 is not going to be used, further in the derivation of our answer. Okay. Okay. So now this is my final stage 2 complete. Now this grouping pattern will not stop here. So this is, you can check that this index 1, or you can say yellow and white, have grouped here, and white and red have grouped here, and red and green, sorry, white and orange have grouped here, and orange and green have grouped here. So earlier there were 4 partitions, now there are 3 partitions. So whenever this grouping will continue, now I will be making groups between these 2 partitions. Okay, that means 1, 3 will be checked with 6, 14, 9, 13. That means now I will be checking all these patterns. Grouping pattern is again, target is again the same. If they differ by 1 bit, I will make the group, otherwise I will not make the group. Okay, again I am giving a shortcut. What is that shortcut? Let's use that. So 1, 3, difference is 2. I will not be checking this 1, 3 with 6, 14, 9, 13, 10, 14, 12, 13, because they are not producing the same difference. Now this you have to keep in mind. If the difference is same, only then grouping will be made. So this is a shortcut which will save a lot of time. So 1, 3 will not be checked with 6, 14. Why? Because 1, 3 difference is 2, 6, 14 difference is 8. So 1, 3, 6, 14, no need not to check. So that means 1, 3 can only be checked with 12, 14. Okay, 1, 3, 12, 14. But if we check that 1, 3 is 0, 0 dash 1 and 12, 14 is 1, 1 dash 0. Okay, so you can see that it is not differing by 1 bit. Although they are having the same difference, but they are not producing a valid group. But we will only be checking those groups which are producing the same difference. So I will not be checking 1, 3 with any other term, and I only checked 1, 3 with 12, 14, and that too I saw that they are not making the group because they are differing by more than 1 bit. Let's proceed further. 1, 9, difference is 8. Difference, same difference, 8, 6, 14, 1, 9, 6, 14. So this is dash 0, 0, 1 and 6, 14 is dash 1, 1, 0. Again they are differing by more than 1 bit. No grouping will be formed. Further, 2, 3, difference 1, 12, 13, difference 1. Okay. So 2, 3, 12, 13, 0, 0, 1 dash, 1, 1, 0 dash. Again, they are differing by more than 1 bit. Need not to write. Proceeding further, 2, 6, difference 4, 9, 13. Again, you can check. They are not making group. But this 4 difference and this 4 difference, 2, 6, 10, 14. If you check that, 2, 6, 10, 14. So 0 dash 1, 0 and 10, 14, 1 dash 1, 0. So they are only differing by this bit only. Rest is dash 1, 0, dash 1, 0. Okay. So 2, 6, 10, 14, they are making a group. So I am taking 2, 6 and 10, 14 because they are participating in a group. So I have mentioned 2, 6, 10, 14. They are making group, and this is the point of difference. So let's replace this with dash. So dash dash 1 0. Okay. So dash dash 1 0. Similarly, if you proceed further, there is no further 2 6 cannot be grouped with any other term. Then 2 10 difference is 8 and this 6 14 difference is 8. Checking these two, you can check that 2 6 and this is 2 10 and 6 14. So 6 14 we are just checking 6 14, is it written correctly? 1 1 1 0 triple 1 0, it is correctly written, and 2 10 6 14. 2 6 10 14 1 dash 1 0. Again they are producing the same thing, dash dash 1 0. If you check that, this is a point of difference. That means this is going to be replaced with dash. Dash is there, 1 is there, 0 is there. So if I group these, so I am getting dash dash 1 0. And the terms are 2 10 6 14. So you can check that this is the same group producing the same binary pattern, dash dash 1 0, dash dash 1 0. So I need not to write that, but important thing is I need to tick that. 2 10 ticked, 6 14 ticked. So to make it clear, I am changing the color. So I have ticked this term, this term, this term and this term. So these terms are ticked. Now grouping these two, making this group and this group, checking for further grouping. 6 14 difference 8, there is no difference 8 in the next section, drop that. 9 13 no difference of 4, 10 14 no difference of 4, 12 13 difference of 1 and 14 15 difference of 1. So they can make, we need to check 12 13 14 15, 1 1 0 dash 1 1 1 dash. So 1 1 dash dash. Okay. So 12 13 is making group with 14 15, we have ticked it. Similarly further proceeding, 12 14 with 13 15, because they are having the same difference too. But you can check that 12 14 13 15, they are producing the same group members and same result. You can check here, 1 is same, dash is same, this is difference. So 1 1 dash dash, so 1 1 dash dash. So it is already mentioned here, 1 1 dash dash, so we need not to write. So this is our complete grouping, and further they are from two different. Now we need to check these as well. Are they making further groups? No, they are not making it. Okay. So this is the last grouping stage. So I can, in fair form, I can write these. You can check that there were few terms which were not ticked. So this is not ticked. So I name it as P. This as Q. No tick, R, S, T and U. So P, Q, R, S, T, U. These are the 6 terms which are not participating further, and these are the terms which I require. 13 and 15 are already ticked. Okay. So P, Q, R, S, T, U. These are the 6 terms. In fair form, you can see here P, Q, R, S, T, U. These are the 6 terms which are the last stage, which are obtained from the last stage grouping. No more further grouping is possible. And P, if you check, what is the value of P? A dash, B dash. That means A has been eliminated, B has been eliminated, C is 1, D is 0. So it is CD bar. Similarly Q, 1 1 dash dash. So it is A, B, and this 1 corresponds to, this 1 has been wrongly done. This is a dash actually. So 1 1 dash dash. Okay, 1 1 dash dash. This is, there is no 1, there is a dash here. So 1 1 dash dash means A, B. Okay, so this Q is AB. Similarly, R, if you check, A bar, B bar, D. A bar, B bar, D. S is B bar, C bar, D. B bar, C bar, D. T is A bar, B bar, C. A bar, B bar, C. U is A, C bar, D. A, C bar, D. Okay. These unticked terms, unticked, are called prime implicants. And now we will prepare the prime implicant chart. So let's proceed further. This is the last stage. prime implicant chart where we have written all the terms here. So this D was not there, which we have corrected in our last slide. Okay. Now the only difference is that if we go back to our first slide where question was mentioned, these 4 terms were our don't care terms, 10, 12, 14, 15. So I have used these terms while grouping in the grouping stage, but while writing the answer, I am not bothered about these don't care terms because I am primarily doing this method to minimize the simplified expression, minimize the expression by grouping all the ones only. I will not be focusing on the don't care terms. So these 4 terms, which 4 terms? 10, 12, 14, 15 are not going to be used further. So that's why I have mentioned only min terms 1, 2, 3, 6, 9, 13. If those 4 terms would not have been don't care and if they were the normal terms, then 4 columns would have been there. Okay, like we had seen in the tabulation method without don't care. Now let's proceed further. P is having 2, 6, 10, 14. P is having 2, 6, 10 and 14 are don't care terms, so I need not to mention. Q is having 12, 13, 14, 15. Q is having 12, 13, 12 is not there, 13 is there, 14, 15 are not there, drop them. R is 1, 3. R is 1 and 3. R is 1 and 3. Then S is 1 and 9. 1 and 9. T is 2 and 3. 2 and 3. U is 9 and 13. 9 and 13. Okay. So we have mapped it. Now we need to check all the columns and search for a single cross. So we can see that this is the only column where I can find a single cross. Okay. So this prime implicant has to be marked. That means P is essential. That means P will definitely be part of my answer. Okay. P will definitely be part of my answer, but I am not saying this is my answer. We need to check that whether that P, essential PI, prime implicant P, is sufficient for my answer. For that I need to check whether it is covering all the terms or not. So P is covering 2 and 6. So 1, 3, 9 and 13 are still left to be covered. That means this essential PI is not going to help me in that case. I need to add some more prime implicants. Out of these Q, R, S, T and U, I have to search for minimum terms which will cover all these terms. So I can check that to cover 13. 13 can be covered with Q and U. So U will be covering 9 and 13. So I can pick U to cover 9 and 13. Then 1 and 3 will be left. So this 1 and 3 can be covered with R. Okay. You can clearly see here 1 and 3 can cover R and S. So R can cover 1 and 3 and this U can cover 9 and 13 and this P was covering 2 and 6. So now you can see that all terms are covered. So now my final answer becomes Y is equal to P plus R plus U. So this is my final answer. You can further replace that P by C D bar, R by A bar, B bar, D and U with A, C bar, D. So in this way we can minimize the problems with don't care using tabulation method. So the only point of difference I am again reminding you that don't care terms will not be entered in the columns of this PI chart. This is the only difference. Okay. Thank you very much.